What's up, guys? It's the Unhinged Engineer here, and today I want to talk about something pretty simple but weird at first glance in PyTorch called same versus valid padding, right? So if you're familiar with convolutions, you're probably also familiar with padding, but just to recap briefly, padding is when you append or prepend zeros to your input vector when you're doing some sort of convolution, mainly to affect the dimensions of your output, right? Which sounds simple enough. I'm going to go through an example here of like manual padding. But what gets a little confusing is that in the PyTorch like function signature for convolution 1D, 2D, etc., you have the option to put in integers or lists of integers, but you also have the option to put in strings, either valid or same. And it's a little unclear, like to the untrained eye, I guess, what each of these means. And so it's super simple. I just wanted to explain it really quickly and run through a couple examples of it because I know it would save me some time when I was first starting out. But first, to look here at the PyTorch API, actually, we have padding and then padding mode, right? So it says here, padding controls the amount of padding applied to the input. It can either be a string, valid, comma, same, or a tuple of ints given the amount of implicit padding applied. So again, it's implicit padding because we're doing the padding within the convolution. And so those are kind of our three options, right? Valid, same, or like a tuple that specifies the dimensions, right? Aside from that, we also have padding mode, which isn't really relevant to this conversation, but I just want to touch on it. You can change the way in which you pad to either zeros, reflect, replicate, or circular. Reflect, replicate, and circular actually take like the values of the tensor and put that in the padded elements in different ways, right? But for 99% of machine learning applications, you're going to be doing zeros, right? Those other modes are more for like digital signal processing type stuff. But let's talk about the padding parameter, which is very relevant to us. So if I go to the source here, here's our class, perfect, conv1d, and let me just do valid. Okay, so that's saying what it can be. Here we go. Okay, padding equals valid is the same as no padding, which sounds simple enough. Padding equals same pads the input so the output has the shape as the input. The same shape, it should say same shape there. Same shape as the input. However, this mode doesn't support any stride values other than 1. So that kind of says explicitly like what's going on between valid and same, but it's easier to understand if you can visualize it. And I found this like huge Stack Overflow chain about TensorFlow, but it's the same topic about how we're padding and how that affects the shape of our output dimensions. And if I scroll down here, I find this awesome GIF from this awesome GitHub repo, which I can make an entire video about in and of itself with like tons of different examples of convolution and code for each. But anyway, back to the task at hand. So if you look on the left here, this is a convolution with zero padding, right? And this is, like it said in the API, equivalent to valid. The reason it's called valid is because you're only sliding the convolution window across valid values. So there's nothing outside of the input value, right? Or the input tensor, excuse me. And in order to fit this 3x3 kernel inside the input tensor for its entirety of the convolution as we're sliding around, you can't go past the edges. And so you get an output that's smaller, right? We go from a 4x4 to a 2x2 here. But for various reasons, you may want to preserve the size of your input tensor even after the convolution, right? And so if you look over here, let's look at this one third to the right. We're padding, we have a 3x3 kernel and a 5x5 input image. And if you look, the output is also 5x5, right? But in order to get the output to be 5x5, you have to pad this extra like border around, right? So now our input tensor is 6x6, right? So a 6x6 kernel convolved with a, 6x6 input convolved with a 3x3 kernel, stride is equal to 1 here. That gives you the output the same as the input, right? At least in terms of shape, not in terms of value. And you can even see over here, right, these examples have output tensors bigger than the input tensor, right? So if you do manual padding, which we'll look at here, you can actually change the dimensions of your output however you want based on how you pad and how you stride. But for the purposes of this video, we're going to focus on same and valid padding. So valid padding is this default behavior where the output tensor is smaller than the input because there's no padding added. And same convolution or same padding in a convolution basically just tells PyTorch, pad it however you need to, such that the shape of the output tensor is the same as the input tensor. So now let's look at some actual code, right? So I'm going to start with this basic padding script I have here, which just kind of shows what you're doing when you do manual padding versus what you're doing when you do padding within the convolution. And actually, let me show really quick. If I go here, let's do, here it is. Perfect, right? If I look at the forward method of the convolution class here, right? Because again, we're using like the class method for when you're setting up models, but usually like 9 times out of 10, that just wraps the functional API. So if you look at the forward method of your class here, you're just calling the forward method, like I just said, but also within that call is a call to f.pad, right? So f.pad is a functional padding function, is a padding function that just does the padding, it doesn't do any convolutions. And that is called within the forward method of the class that you instantiate with all the pretty attributes and everything. This is all just PyTorch trying to make it easier to use. But I actually have here 2 examples of convolution. One where I do that padding outside the convolution, and the other where I use the padding attribute in the class, right? So when I run this basic padding, you can see here that I have padding equal 2, 2. So that means 2 on the left side and 2 on the right. And then I pad the tensor, and I call it something new, aka padded tensor. And if you look here, I printed out the step. There's 2 zeros on the front, and there's 2 zeros on the end, right? And so when I do the convolution here, where is it? Conv layer padded tensor. I'm not calling padding again because then we would double up. You're going to get, I should have the shapes printed here. Yes, I do. Padded tensor. So right, so 2 on each side. So we go from 10 to 14. And then when I do the convolution, it goes to 12, right? And here, I do the same exact thing, except instead of doing padding on the outside, I use the padding attribute of the conv1d class. And you get the same exact behavior, right? We pad it out to a 14. I don't print that because it's like an intermediate value. There might be a way to print that. I probably should figure that out. But anyway, you pad it out accordingly, and then you get 12 as your output tensor shape. And let's do something fancy here. Let's do like 5, 5, right? So now if you look, the output of our manual padding is huge. It's 18, right? Even though our input vector is 10 long and our kernel is only 3, right? Because I've padded 5 zeros on the beginning and 5 zeros on the end, right? So if I wanted for whatever reason to like have an even bigger tensor going into the layer after this convolution, I could. One quick thing to note here. So if I do 5, 3 as an example, you can do asymmetrical padding if you do this manually, right? If you call the f.pad outside of your convolution, you can be a little trickier with it. So here I have 5 zeros in the front and 3 zeros on the back, and you get 16 as the output layer, right? Output layer shape, excuse me. Now, I thought that you could do this. I would appreciate a comment from somebody. I thought you could do like asymmetrical in this attribute as well. For some reason, it's yelling at me that I'm not doing it right. So if I'm being an idiot, drop a comment and tell me how to do it. But I thought you could do that. It seems like it's a little more finicky. But yeah, if you want an increased degree of control, you can always like, do it yourself outside of the convolution function. Or I'm just being a moron and I'm not doing that right. But let's talk about same versus valid again, right? So here, I have the same kind of structure where I do it with the API, but I also do it outside the API. But I have 2 class methods here, one with same and one with valid. I have the 10 long convolution tensor here, or convolution input tensor here. And yeah, we're doing some stuff. So let me run this script. Okay, so if we look here, our padded input is 12 long. Because I'm putting 1 on each side, right? And again, 1 0 in the front, 1 0 in the back. And then after doing that padding, you get an output tensor of 10, right? So when I do the same convolution, PyTorch figures that out for me. So here I did manually, but PyTorch does it itself when I call the same attribute. When I call the valid attribute, it doesn't do any padding. And as a result, our output tensor is 8 elements long. So, you might want that behavior, you might not. And again, like I said earlier, I can just do this, just for argument's sake. You know what? Let's leave the same. Do padding equals 1. There we go. So if you look here, there's actually a discrepancy because I didn't change it in the manual. But if you look here, 1 on each side is the same functional behavior as calling it the same. So yeah, it's not like a very complicated thing here. It's just kind of a class attribute with two possible values, or I guess 3 if you count manual. But yeah, it's a little confusing at first glance, and I thought like this video might be able to help somebody who's just kind of getting started with PyTorch. So yeah, if you enjoyed, if this is valuable, like, comment, subscribe. Like I said, I'm the Unhinged Engineer. I make content about software engineering, aerospace engineering, autonomous vehicles. Basically any cool shit in engineering I make content about, both technical and professional development. So yeah, if that's something you're interested in, get involved in the channel. Thank you so much for watching, and I will see you in the next video.